Alright, so now we're on part 3 of our midterm geometry review. Alright, so let's start off with number 22, where it says if triangle TRI is congruent to triangle ANG, which of the following congruent statements are true? So again, with this one, if you have a congruency statement, the first letter matches with the first, second matches with second, third matches with third. So the best way in this is just kind of compare and make sure that these actually are matching up. So on the first one, it says TR and AN. So TR is first and second, AN is first and second. That one works out. So A works. So the next one is TI and AG. So TI is first and third, AG is first and third. So that one works. Next one's RI and NG, which is second and third. So that works. The last one is TI and NA. So TI is first and third, NA is first and second. So that does not work. It is not going to be D. Moving to the angles, angle T and angle A, first and first, that one works. Angle R and angle N, that would be second and second, that one works. I and G, third and third, works. A and N, however, does not work because again it's going to be the first on the second one, but this and then the second one on the second one, so it's still not even different triangles. Alright, number 23 is very similar. It gives us the statements. It wants us to find angle A. So if we look at A matches with M. So we're going to look at M on the other one and see if there's an actual value. And look and behold, we get an actual value. So that means A has to be the same one. So your answer is quite simply 38. Now, if you had to do other things, like if you were finding angle C, what you'd have to do is do 80 plus 38 and then subtract from 180 because again, triangles add up to 180 degrees. But it's just a matter of case about what you're given, what you're looking for. Number 24 has us have two triangles and it gives us some parts of it. First says MN is the same as QN, so these two parts are the same. PM is the same as PQ. And the other thing that we know will be the same in the middle is this line because it's the same line, so that would be a reflexive property. Anyway, looking at this, we've got these triangles congruent by side, side, side. Therefore, all the corresponding parts are congruent, working through it. Anyway, we're going to label the parts and we're going to work through it. We want to find X and Y. We're told that MN is 4, QN is X plus 2, QP is Y minus 1, and MP is 13. Sorry, I did that in a little bit of different order, but again, it's just basically copying down the parts. So if we're looking for X, X is up here, it matches up with the 4, so we just do a statement where we say, well, X plus 2 equals to 4, subtract 2, and X equals to 2. So there's our X. For the Y, well, we got the bottom part, we got Y minus 1, and we got that equaling to 13. So we do the same thing. Y minus 1 equals 13, add 1, and Y equals to 14. So our answers for this one is X is 2, Y is 14. Alright, so number 25 is another one that's very similar to it. It tells me that XY is the same as UV. VY or YZ is the same as VW. And then ZX is the same as UW. Alright, then it tells me that UV is 11. VW is 8. And then WU is also 11. Okay, so again, these sides might not be drawn to scale, but it gives us a label. Alright, we're going to do the other parts. It says XY is 2K minus 5. So XY is 2K minus 5. YZ is K. And then the next one is K plus 3. Now it wants us to find the value of K. So I could plug it in with any of these three. However, there's a very simple one. Since zy is k, zy matches up with the side that is 8. So, fairly simple. Your answer is 8. But again, if you did it with another one, say we did k plus 3 equals 11, we'd subtract 3 and we'd get k equals to 8. No matter what, you're going to get the answer to be 8. It's just some of them might be easier than the others if it's something like this. On number 26, we're looking at these ones being congruent. It wants to know what transformations are done to go from one to the other. So again, multiple choice test, you can just kind of do process of elimination to see which one of these ones work. But for this case, I've got to do this by hand and figuring it. So this top one, JKL, does not look in like the same orientation as the other one. What I have to do on that one is I've got to flip it. So I'm going to flip over the x-axis or the y-axis. So that's a reflection over the y-axis. But after I do that, I still need to do a little bit more, and I'm going to slide it down. So again, the slide is a translation, and this one is specifically 5 units. And you got to say which direction, so that would be down. Again, on multiple choice tests, just look at which ones there are, figure out the results. Number 27 says which of these proves these are congruent by side, side, side. So I look at this, I already have BC congruent to FE, AC congruent to FD. We're just worrying about the third side. So we got one side of this being 5x plus 2, the other side is 37. We just set them equal, subtract 2, 5x equals 35, divide by 5, and x equals to 7. So for this to be congruent by side, 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 x would have to be 7. Alright, number 28 says the path shown on the part justify the statements to say that this is that triangle, and it's going to be JKN, top triangle here, is congruent to MLN, the bottom triangle here. So we got to figure out how these are congruent. So notice we have the 400 here, the 400 here, those match. Okay. The 800 matches up with the 800, so we have those parts matching. Let me zoom in a little bit better for this one. So when we're looking closer at this, we actually end up having sides that are congruent with the angle between, the 90-degree angle. So notice that we have an angle between two sides. That statement would be side, angle, side. There's your answer. Number 29 says that we have BD, which again would be this entire diagonal here, which isn't really a diagonal. It's congruent to AC. It wants us to say how we would know AB is the same as CD. We have to basically figure out how we're going to really say two triangles are congruent. So we have a big triangle that is ADB and another triangle that is ACD. Right. Now notice that we have the corner here 90 degrees. What we basically know is now AC is the same as BD, but we also have the bottom being the same because it's the same line. So I actually was following this line. The 90-degree angle here goes to the side AD, which goes to the side BD, and that matches up with the 90-degree angle going to AD and AC. So we've got an angle next to a side next to a side. Now again, this does not work in normal situations. The only time it works is if the angle is 90 degrees, which happens to be this case, so it ends up being hypotenuse leg. There's your answer. On number 30, we've got a jogging path running along figures here. It's basically saying, how do I want to say that these two triangles are congruent? Okay. Now, there is a typo in this, or it shouldn't be DEF, it should be a DEA, but that's not the case with the matter of it. What we're really looking at, this is the picture here. We should have the angles here in the middle congruent because they're vertical angles. The 100 is the same as 100, Therefore, we got an angle, which is a 90-degree angles at C and E, congruent to the side, which is like the 100s, and then the angles at A. So we've got an angle next to a side next to an angle, so it should be angle, side, angle. Alright, so on number 31, we're actually just going to use this to solve for x. We're not going to really worry about too much of the other things. We're going to solve, it says solve for x and find SRT. Again, it won't really be that hard. It says that this is an isosceles triangle where RS is the same as ST. So that means these are the same. So, if those sides are the same, the angles across from them are the same. I know that r is 4x minus 20. I know that t on the inside is 4x minus 20. But the nice thing about this is since the angles here add up to, or make a straight line, they add up to 180. So we can make a very easy equation for that. 180 equals to 6x plus 4x plus 20. So, combining like terms, 6x and 4x is 10x plus 20 equals to 180. We're going to subtract 20. And 160 equals to 10x. Divide by 10. And 16 equals to x. Alright, but again, we're not done because the other part of this one wants us to find SRT, which means we're going to plug into 4x minus 20. We're going to do 4 times 16 minus 20. 4 times 16 is 64. Minus 20 gives us a value of 44 degrees. There will be your final answer for finding SRT. Again, you kind of worry about the properties of isosceles triangles. If the sides are congruent, the angles are congruent. Alright, so problem 32 says it wants to order the sides from longest to shortest. So what we need to do is we need to figure out what this third angle is. We add the two that we know, 58 plus 62 gives us 120. 180 minus 120 gives us the third angle 60. Now, the side lengths are relative to the angle lengths across from. So if we're going from longest to shortest, we look at the longest or the largest angle. The one across has to be the longest side. So we would start off with IJ. Okay, so IJ is first. Right, then the next one would be 60, which is the J, so across from it is IK. IJ, then IK, and then the shortest of them would end up being JK. Again, all you have to do is find the side or the angles, and the sides work with it. Number 33 says, ask if this can be a triangle. So the way that you determine if a figure can be a triangle is you add the two smaller sides, and it has to be larger than the third side. If it's equal or less than, it doesn't work. Okay, so on this one, the two smallest ones are 5 and 7. So 5 plus 7 is 12. 12 is bigger than 11. So yes, this can be a triangle. Five plus 7 is larger than 11. Alright, number 34 shows a diagram about distances from Houston to Dallas and from Austin to Dallas. What is the ranges in distance from Austin to Houston? So we have this on a triangle with this. If you're worrying about the possible ranges on this, okay, we basically set up an inequality. So we're going to have one side that's less than, one side that's greater than. Okay, the short end would mean that this is the shortest part, so we would have to have it between these. So the best thing to do is on one side we're going to subtract. So 240 minus 200 gives us 40. Alright, so that's the low end. It would be less than x. Right? But we also have to do the high end where we're going to add the two that we know. 240 plus 200. And that would be the high end, which is 440. So your answer on this one is between 400 or 40 and 440. And really, since there's units, you'd have miles. Number 35 is a hinge theorem problem. Again, we're comparing the angles at ABC to triangle CBD. We want to know which one's bigger. Right? The sides 12 are the same, and the side BC is the same. So we have the angle between the sides. So yes, this works for the hinge theorem. We just have to figure out which one of them opens up to the bigger angle. So when we see this, the 10 is bigger, so therefore the measure of angle ABC has to be bigger than the measure of angle CBD. Again, the bigger the side, the bigger the angle. Alright, so for the next one, it says for two isosceles right triangles, what is not enough information to prove triangle or prove congruence? So we know that it's isosceles and right. So basically on this, the only possible way that you can have an isosceles right triangle is that the two legs are the ones that are the same. Okay? Because we couldn't have the hypotenuse be the same because the hypotenuse has to be bigger than the other two ones. It can't be bigger and equal at the same time. So we're going to have two triangles where we're going to have the legs already the same. We already have that kind of locked in. Now it's just a matter about figuring out which ones of these ones apply. So the length of all sides of the triangle, would that be enough information to prove it? Well, if we know all three of the sides for both of the triangles, yeah, we could easily tell that that's enough information. Okay, so it's not A. The length of the hypotenuse of the triangles. So on this one, basically all we would be given is the hypotenuse. But with that being said, how it is, on a right triangle that we know two of the sides are the same, if we were to set this up, we'd have x squared equals to some number. And we would actually know this value. We would have it being something. You could say that it is, instead of being x squared, we'll go with the length would be 4. Let's say that. Right. These two parts have to be the same. Again, these two parts we would end up figuring out. So if we knew the hypotenuse on both triangles, then we ended up saying this. We'd have y squared plus y squared if we're doing Pythagorean theorem, and that gives us a total of 2y squared equals to, in this case, 8. Nope, not 8, 64, or 16. Okay. So we get 2y squared equals 16. We would divide both sides by 2, and we get y squared equals to 8. We could square root that, and based off of that, we end up getting that y equals to the square root of 8. Now, is the square root of 8 a number? Yeah, it might not be in simplest form, but it is a number, and we would be able to compare those numbers to the other ones. So we would technically have all three sides to be able to compare. So the length of the hypotenuse of each of the triangles would be able to tell if those are congruent or not. Alright, C says the length of a pair of corresponding legs. So again, basically with this one, it would be like you were told one of these legs. So like I would know what this y is. Let's say that that was 4. So if that side was 4, then we know this side was 4, this side was 4, this side was 4. We actually have that already set up where we have the angle between those ones congruent. So that would technically be angle side angle. Again, you could also do Pythagorean theorem and find the other one. So it doesn't really help that one. But anyway, we basically show that we can do it. Now the last one says the measure of the non-right angles. Now granted, we know that these two angles would be congruent, right? But there's really only one possible way of it being congruent and that being 90 degrees. That'd be that those are 45. But if we only knew that those angles were 45, does that tell how big that shape is? I'll tell you no, because if you have a shape that is close, I could have another shape in here that still is isosceles with 45-degree angles, and they obviously are not congruent to each other. So just having the angles does not prove it. Again, angle, angle, angle does not prove triangle congruence. And that's going to conclude video 3. We've got one more part to go over, and that will be starting shortly.